Hello students. Today we will discuss about different classes of computers. As per the previous session, we have seen the various performance growth that happened from the earlier 70s to 2000, and we have seen the different reasons why we had these performance growth. And one of the reason why we had this performance growth was due to the invention of because of that growth we had one thing, that is we have invented a number of classes of computers. So today's sessions we will see the different classes of computers that are available or that was being created during the performance growth happened from the earlier years to the current years. So the basic classes of computers are, first one is the personal mobile devices, which is usually called as mobile phones nowadays, which is shortly called as PMD, portable or personal mobile devices. And the second category is called as desktop computing or desktop computers. Desktop computers or normal PC computer, personal computer, which was actually mainly for desktop or personal office usage and all. Then we had a third category or class of computer which is called as servers, which is actually requiring more capability, more capacity, and which should have more functionality than a normal desktop computer or as a personal mobile device. Then we are having one more class of computer which is called as either cluster based or warehouse scale computers, which is usually used for storing huge amount of data into the computer system. And the last category is the embedded computers, which is usually used for specific devices. The computer is embedded, which won't be having the full functionality of a particular computer, but for some computation with some electronic devices we need to add or we need to embed a particular computers. That category is called as embedded computers. So these are the major categories or classes of computers which was invented during the performance growth period of the computer systems. In the remaining slides we will see the different classes in detail. First one is as I have mentioned earlier, personal mobile devices. As you know, the features of personal mobile devices are actually wireless devices. So it is very portable. Anybody can use the device from any location. And nowadays all the mobile devices are having all the multimedia features, multimedia user interfaces with user communication. Earlier we had only very simple phones with simple SIM cards and other basic features, but nowadays we are having a mobile device with many features that is having similar to a perfect computer system itself. So we can do anything that a computer can do by using that very small portable personal mobile device. Some of the examples are mobile phones, mobile tablet, which is slightly larger than mobile phones, and we are having mobile computers also, which is usually called as laptops. Mobile computers are called as laptops. Then we will see different features of these personal mobile devices. First one is it is energy efficient. Mobile devices are energy efficient, which can utilize the energy more efficiently. Means, as we know, mobile phones are being charged by using a charger, and we will be mostly after the charging of that particular device by using power, we are giving energy, and that energy is being utilized for the operations of that particular mobile device. So sometimes we'll be using some WhatsApp messaging and all, sometimes we'll be watching some movies, sometimes we'll be looking into the emails, or we'll be browsing through the internet, etc., etc. So the mobile device requires energy for different tasks or different processes that are within that particular mobile devices. So with that charging, we'll be getting some power. So this power is being converted into energy when it is specifically connected with a particular task. So more tasks can be done by using very less energy. That is the major property of, because we are having a very small screen only. So for display and all, we don't actually require more energy like a very large device. Similarly, for different operations, it uses means less energy. So if it is using only less energy, more time the device will be active. So one of the feature is it is energy efficient. Then second one is power efficient. Actually these two things can be compared actually, because of the power only the system is getting the energy. So power can also be efficiently utilized, because if you charge for some 1 hour, the power can be utilized for various distributing among various boards and internal devices available with that particular system. Because not only for a particular task, for communication between or within the device board and all, for every connection it actually requires some power. So normally when you compare with a large PC and a mobile device, this small mobile device requires only less power when compared to the larger computer devices. So these two are interrelated. The mobile device requires only less power, and it also requires only less energy for performing various tasks in the mobile device. Then some other features like responsiveness. Responsiveness is one of the major feature of a computer or mobile device, because when we access a web page in a normal personal computer, the screen size itself is very large, and we are usually looking into the site in a very big screen. But when we are accessing the same site in a mobile device, we are that same page is being compressed or reduced into, or it is trying to fit into the size of that particular mobile screen. So that property is actually called as responsiveness. According to the size of the device screen, that display will be adjusted automatically. So that new property is being added into the mobile devices, and nowadays we are using the devices with very small screen, and every web pages are created in a responsive format itself. And also predictability. So many things can be predicted, because nowadays we can use the mobile device for finding the route of a particular location, or finding the weather details and all. So many features are being added into the many things can be predictable by using the mobile devices and various other features associated with that particular mobile devices. So these two are the key characteristics of any media application: responsiveness and predictability. And the next point is it actually minimize the memory. Okay, so when we use a mobile device, we are actually utilizing only less amount of memory, because we will be having some like 4 GB RAM memory, and we'll be having some 64 GB or 128 GB as the internal secondary memory. But for our PC, laptop and all, we are using some even slight bigger RAM, and we'll be having more storage, secondary storage, like some 500 GB or terabytes of secondary storage we are using. But the same thing can be done with the with less memory, because we actually require memory, very less memory because our screen size is less. Accordingly, everything is less when it is opened in a particular mobile device. So normally it requires or it need a very minimum amount of memory. So these are the properties of the personal mobile devices, which is very common nowadays. So that is why which is taken as the first class of computer, which was actually invented in after 2000 only. Because before 2000 we had only the other connected devices, but wireless mobile devices was introduced in the later 2000 only in India. Okay, so some other countries started using that before that itself, but in India we started using only after 2000. So nowadays after 2010 it became more popular, and nowadays everybody is having their own mobile devices with them. So one of the major class of computer, that is mobile, personal mobile device. Now the next category is the desktop computer or desktop computing, which is the process desktop, which is a slight larger computer system. It spans from low end system that sell under means around $300 to high end like heavily configured workstations like with $2,500. So a personal computer, a desktop computer, which can be brought by using only $300, and also with more capability, because many even when we take a laptop, which is actually not equivalent to a desktop computer, but which can be equated, because both are using in the same way only, but only thing is we can carry that laptop. Okay, so even when we consider a laptop itself, we can buy a laptop with very small amount like around 20,000, and also we'll get a laptop with more than 1 lakh, 1,50,000, etc., with more capability, means some gaming processor and all. Gaming laptops cost more because which requires more RAM capacity as well as other capabilities. So desktops varies in different prices, depends on the specification of that particular desktop computer. So from 2008 onwards, after 2008 we actually started using laptop. Before that we had only personal computer, but nowadays only for office purpose many people are using desktop PC, but most of them are using laptops, which is actually not considered as a mobile device, but it is also similar to a desktop PC. Now desktop market trend tends to be driven to optimize price performance, because even laptop costs more when we compare our normal PC. So in the market the price performance, it depends on the specification that is required by a particular user. So desktop computers are being utilized by many of the offices in the markets, I mean shopping centers and all. They are actually using desktop computers, and the performance varies according to the specification that is given by the company, or that can be brought by the people according to their requirements. So this is the second category of or second class of computer, which focuses on more official or study related computing or communication with the system. Now the third category is called as servers. So as the name suggests, server is a special category of personal computer with more capability than a normal personal computer. So the 2 points to be focused on a server is it should have larger scale, because more operations to be performed on a server, because server is the machine which serve different clients. So a number of clients will be given request and more requests to be responded. Means some response must be given, some performance must be done according to the request. So it must be in larger scale, and also it must be reliable, because we should always believe, because if I am trying to access some content from a server, for example from Gmail server, if I want to retrieve my email back, it should be always available, it must be reliable. So it should have similar type of means more operations to be done, as well as it must be reliable also. It must be always we must trust on the server to which we are giving the request. So server was replaced from the traditional mainframe, which was the server itself was earlier, sometimes it was called as mainframe and sometimes it was called as mini computers. So all this was actually replaced with the name server. Now the features like availability was the critical feature, that is every time the data must be available. So if I am trying to access a YouTube video from the YouTube server, now if I search on a particular data, that must be always available within the server, which is the crucial feature of a particular server. So more capable with more memory and more processing power, etc., etc., all these are required for a particular server than a normal PC or a mobile device. Now second feature is scalability, that I was mentioning here, means ability to scale up the computing capacity. If one or two requests is being gained by the server, it can do it freely. But if more requests arrives to the server, accordingly it should scale up, because more process to be done, to be completed within the given amount of time. So it should be scale up. If more requests to be responded, it should be done in that way. It should actually scale up the performance. If less amount of requests arrives, it can do that, but if more requests arrives, it should be scaled up accordingly. Similarly, the memory, the storage, etc., etc., because if we want to download more data from, accordingly that that performance must be scaled up, because sometimes I want to download a video, as we know it is a large process than downloading a simple word file. So accordingly the server must act for accessing the data from the memory, and it should also focus on the IO bandwidth, because in our client side we will be using some input device where we are typing some data, some input is given and the output is generated by the server. So from the client as well as server side, the network and the speed will be varying. Server side processor and client side processor, the speed, the network speed also varies for both sides. So accordingly it must act for getting the response or giving the response to the client for a particular purpose. So these are the features, like availability is one of the major feature, scalability is another important feature, and another important feature is they are actually designed for efficient throughput, means more operations to be performed within the limited given time. Suppose 10 requests arrives at a particular minute, all the 10 requests must be responded within that given time. So how many operations can be done in a given time, that is actually the throughput. So if it is having more throughput, which is more capable server. So a throughput is actually the number of requests that can be handled in a unit time, which is actually the crucial feature of a server system. How many requests can be handled in a unit time. So servers are special category of personal computer which is having more capability, more scalability, more reliability, more availability, more throughput. So all the features must be there than when we compare with the normal desktop personal computer. Now another category of class of computers, either cluster or warehouse scale computers, as the name indicates, which is usually used for more storage. So a collection of desktop computers or servers. So a number of computers and a number of servers, they are connected in a LAN network. So for this particular class of computer, a single machine is not enough. A number of servers or number of computers are connected through a LAN network to act as a single large computer. So in every our previous, like personal mobile, a single device, personal computer, desktop computer, a single computer, server, a single server. But this is for large scale. A number of computers are connected by using a network. So in large scale usage, so because if I want to, even for YouTube and all, we are not accessing a single device, because many computers are connected to the YouTube server, so that many similar category of videos are stored in that particular it cannot be stored in a single server. Okay, so in a large scale we are using the server and desktop computers together. So in that situation, each node runs its own operating system. So every desktop, so some desktop system will be having its own, means some will be using Windows, some will be using Mac, some will be using Linux, etc., etc. But the nodes communicate using a network protocol. Just using some network protocol, even if the OS is different from different devices, they are actually communicated by using the LAN network. The largest of the clusters, so as the name indicates, clusters, group of desktop computers or servers. The largest of the cluster, which is usually called as a warehouse scale computer. So among these set of all computers and servers, the largest of the cluster is called as warehouse scale computers. So these two are actually given together, cluster or warehouse scale computer. So the largest among those cluster is actually called as warehouse scale computers. The price, performance and power are critical to warehouse scale computers, as they are so large. Price will be always more, performance to be considered, and power requirement also very important for a warehouse scale computers, as because of the huge size of the special category of computers. So WSCs are related to servers in that availability is critical. So it can also be act as a large server with more desktop computers and servers being connected, which can be similar to a server. So as the server says, it also requires availability property, which is critical. Now supercomputers are actually related to WSCs in that they are equally expensive. Supercomputers are actually similar to this warehouse scale computers, where more processors are connected together, which is more expensive. Now WSC warehouse scale computers emphasizes on interactive applications, large scale storage. There you can say YouTube, large scale storage, interactive applications like movie on demand and all, dependability. Sometimes if I want to store, so if I want to store my lecture video, I'll be always trusting on YouTube, and I'll be storing that. So I will always depend on that, because if I want to retrieve that, I can access that warehouse scale computer. And it also require high internet bandwidth because as it is connected to the LAN network and many computers are being connected, the network speed is also an important factor. So this is another class of computer which is used for server, as well as server in the sense for performing various operations, as well as the importance is given to the storage or access of more data from the server. So the next or last class of computer is called as embedded computers, which is a special category where a machine actually consists of some simple embedded microprocessors. So some microprocessor chip will be associated with a device, like in a washing machine will be having a chip that is in a machine, the chip is being placed. So only the chip will be performing some operation. It is not like a full-fledged computer. It is only for a special purpose that embedded microprocessor is being utilized. So embedded devices are more limited in hardware and software sophistication, because for a washing machine it requires some chip for all this arrangement. For lift they are using some microprocessors for some arrangement, for oven, and for several devices, even with TV screen, TV in car also we are using some embedded microprocessors for various applications. So all these are for specific purposes. Some computing chips are being associated with that particular hardware. Embedded systems have the widest spread of processing power and cost, because as you know, even if it is using a simple chip in a car, for a car or for a washing machine or similar devices, always the cost is more. As we know, the cost is more because these microprocessors are specific to the working of that particular machine. The primary goal is to meet the performance need in a minimum price. So maximum performance to be gained with a minimum price. So we are if you want to buy a a washing machine, we are looking for a better performance machine with a minimum price. So price may vary, accordingly the performance may also vary. So this is the last class of computer which is called as embedded computers, which is specifically used for some specific task. Some microprocessors are embedded within the machine, like a washing machine or a car or any similar devices. So these 5 are the major classes of computers that was invented during the performance growth period from 1978 to 2000, around 2006. Now we are having one more classification of computers. For that classification we will see a mechanism that is called as parallelism. We'll see that in brief. So there are 2 types of parallelism. So as the period 2006 and after that and even before that also, within the uniprocessor, single processor, we need to have parallelism, but every time it is not always possible. So that is why we started using multiple processors. Even with the single uniprocessor or with multiprocessor, we need to have some parallelism to be implemented within the system. So there are 2 categories of parallelism. One is called as data level parallelism and second one is called as task level parallelism. Data level parallelism or DLP is actually when we are using more data items to be performed. For example, if I want to sort a very huge data, so the data is very large. That situation we need to have dividing that data into subparts and process that. There we require data level parallelism. But the second one is task level parallelism. It arises because tasks of work are created that can operate independently and largely in parallel. If the task is very large, you can divide the task into different subtasks, and those subtasks can be executed in parallel by using multiple cores or in an interleaved manner if it is a uniprocessor system. So there are 2 categories of parallelism. Generally talking, we'll be looking into parallelism and other details later in the same subject. So this data level parallelism and task level parallelism can be exploited in 4 major ways. First one is by using instruction level parallelism. Instruction level parallelism, it exploits data level parallelism at the modest level with compiler help using ideas like pipelining. Data level parallelism Pipelining is a mechanism that is used for implementing parallelism. So instruction level parallelism internally within the processor, if more instructions to be executed at the same time, or some instruction to be given for a very large data, we require instruction level parallelism. That situation, it can perform the parallelism by using pipelining. And at medium line we are using speculative execution, or like for increasing the speed or improving the parallelism, we are doing some optimization. That is what speculative execution, for improving the instruction level parallelism. Then a second usage is when it comes to graphical processor system and all, or like vector architectures and graphical processing units. We require more data to be processed by applying single instruction to a collection of data. Here also we are looking for huge data to be processed simultaneously. There we require the usage of data level parallelism. Similarly, the third one is thread level parallelism. It exploits both data level parallelism and task level parallelism for tightly coupled hardware that allows interaction among parallel threads. So a large task can be divided into multiple subtasks, and if that different tasks to be executed in parallel, we can use thread level parallelism. So many languages are using thread level parallelism for processing more data, as well as especially for processing more tasks we are using thread level parallelism. Then the last category is request level parallelism, which focuses on it exploits parallelism among largely decoupled tasks. That means it is according to the user request or the request from the operating system, the different tasks can be executed in parallel. So thread level parallelism is for tightly coupled, but request level parallelism is for decoupled task, because separate task that is to be executed in parallel. Here thread level parallelism, they are tightly coupled, means similar common related tasks to be executed in parallel. So these are the different ways to implement means the usage of data level parallelism and TLP. They are applied in these various situations. And according to these parallelism, there is a different classification of computer which is called as FLINS classifications. So just for mentioning these classification, we were describing about the parallelism and two categories of parallelism. So based on this parallelism, we are having some categories of computers. One is called as single instruction stream, single data stream, which is usually called as SISD. Single instruction, single data stream. This category is actually applied to uniprocessor, single processor. A single instruction will be given and single data will be given, and that will be executed in normal way. It can exploit instruction level parallelism because the same instruction can be divided by using interleaving or pipelining, so they can have instruction level parallelism. A single instruction is given to a single data. Now second category is single instruction stream, multiple data streams. So a single instruction is given to multiple datas. More datas are there, but single instruction is available. So the same instruction is executed by multiple processes. So there we can have parallelism by including multiple processes using different data streams. It also exploits data level parallelism because multiple data are available, so data level parallelism can be exploited. So a single instruction, multiple data. So the same instruction can be applied for multiple data in parallel. So that is another classification of computer. Then third category is multiple instruction and single data stream. So more instruction that is applied to a single data stream, which is a classification available by FLINS, but the problem is there is no such multiprocessor available of this type, because normally we won't require multiple insertion for a single data to be executed. That concept is not yet being implemented. So, but that classification is also available among the FLINS classification of computers. And the last category is multiple instruction stream and multiple data stream, which is a combination of the first and second. Multiple instructions are available, multiple data streams are also available. So there we can exploit both task level as well as data level parallelism by using multiple processor. So we require each processor fetches its own instruction and operates on its own data. So one instruction will be given to one processor and corresponding data. Second instruction is given to second processor and it will access its own data. Then next instruction will be given to next processor and it will access its own data. In that way, multiple instructions and multiple data can be processed in parallel by using MIMD computers. So this is when compared to normal class of computer, this is a special category, special classification only based on the parallelism concept, SISD, SIMD, MISD and MIMD. In that, MISD is not yet being implemented, nowhere it is being utilized, but other three are very common. For exact multiprocessor, the fourth category is most commonly used, and first and second for both instruction level and for data level parallelism, both these categories are also being utilized. So that is all about the different classifications. So today's lecture we were discussing about the different classes of computers that was created based on the growth in the performance of computer from earlier stage to the current stage, and we have also seen a special classification of computers which was defined by FLIN based on the parallelism concept. So that's it for now. Thank you.